If you're using a Pseudo 12S module, there's an extra step here, and it is absolutely critical that you do it. If you do not do this step, you could be exposed to high voltage later on, and it could electrocute you. It could energize the entire car, you could die, etc. So what we need to do is take our 12S PCB, and there's the BMS connector this side. You're going to put that on the side the BMS connector is, and you're going to basically just slide it in this rail right here. We haven't actually loosened the rails yet. And what we need to do is we need to center this PCB to where you have the same gap, say 0.5 millimeter on each side, like so. That's about right. And that is from the outer face to the edge of the PCB. What we're going to do next is take a Sharpie here, and we are going to put a mark straight down, get this right in the center of frame here, straight down, and I actually can't see it with the camera in the way, right there like that on the edge of that PCB. We're going to do the same thing over here. I'm going to do it a little bit off to the side so I can actually see what I'm doing, like so. Okay, so we've made 2 marks. We only need to do that on one side. What these marks are going to do is prevent this circuit board from sliding this direction or that direction. If that happens, and this high voltage touches this piece of metal or that piece of metal, depending on which way it slides, then this can energize the chassis in your car. You are really playing with fire if you skip this step, so do not skip this step. So the next thing we need to do is we're going to remove this PCB, and we're going to take this bracket off entirely. What we need to do now is take a hacksaw and cut right where these lines are. So I have this bracket mounted to a table with some clamps, and here is the mark that we made. I want to make the kerf, which is the width of this blade, I want to make it to where this black that we drew on here is just barely visible, so I want to cut towards the inside of the bracket on both sides. A rotary cutting tool might be a better application here, but once we can get started, will be good. I don't want to cut all the way through the bracket. I want to cut maybe 2/3 of the way through this flange. We're going to do the same thing on the other side. And once again, you can see there's my mark right there. And with this view, it's going to be a little bit harder to see, but you want to cut on the inside edge again. You want to make that mark mostly visible, if possible. Like so. You can see I can still just barely see that black mark. Now what I'm going to do is I'm going to take a vice grip or other type of clamping device, and I'm going to grab the outside of this flange, like so, and grab it tight, and I'm just going to bend it down like that. We want to make sure that this is going to interfere with the PCB so the PCB can't slide forwards and backwards. And we're going to do the same thing back over here. We're going to bend the outside of the flange. We're going to grab it here with our plier, and we're going to just bend it down like that, so that when we now reassemble this module, the PCB cannot slide forwards or backwards. Here's what those bent flanges should look like. You can see here's where we've bent that flange with the plier, and you should see that if an object were to try to slide along this plane, it would get stopped there. That's going to keep that PCB from sliding on both sides. You can see the same thing over here, if it'll focus. There we go. You see this flange is bent down. You can see that our PCB is not going to be able to slide past that. So what we're going to do now is reassemble this side piece that we removed. So now that we have this end piece installed, we need to look down and see on the downturned flange here, the edge right there, we want to make sure that these downturned flanges are basically coplanar with this surface right here. That's where we're getting all of our straight edges on. In this case, I'm not. In fact, this one's a little bit too far in, which is fine. And this one is also a little bit too far in. So what we need to do is remove this again. In this case, we will turn both of these down because in both cases, this down lip is inside the outer walls here. If one of these lips is outside the wall already, you don't want to downturn it more because this is trying to center the PCB. So in this case, we're going to basically turn both of these down just a little bit more. So we'll pop this back off. We will take our vice grips and we'll basically turn this in just a little bit more. As we turn this down, because we're bending the metal, it's going to cause a wider gap to form, like so. So I've just turned that one down more. And now I'm going to turn this one down more too. And another option here is you could use a rotary tool. You could basically cut a little bit more off that if you needed to. So we're going to go ahead and put this back on again. Now in this case, we're pretty close on both sides. Let's see if our circuit board fits. In this case, it's really close, but not quite. It doesn't quite fit. So I'm going to need to take and just cut a small part. You can see that there's about probably 1 millimeter of interference there. So I'm going to go ahead and cut this off. I'm going to cut just a little more off that tab with the hacksaw. So again, I'm going to cut just a little bit off of this inner lip here. And again, this is where a rotary tool could be very useful. You'll definitely want to vacuum all of these steel chips up. So yep, now it does fit. That's great. And also you want to make sure at this point that the PCB cannot overshoot either edge. So basically this edge or this edge. The whole point of this exercise is to make sure this circuit board cannot slide left and right. There's about 4 millimeters of slop if you're off before you're going to have problems. In this case, you can see I have about a 1 millimeter gap on this side, and I have basically flat. I mean, it's maybe a few hundred micrometers, but that's totally fine. You could be a millimeter over each side. Now, if you do mess this up and you say cut this flange way too far that way or that one way too far that way, you can always just flatten these flanges back out and start again on the other side. Only one side needs to be done, so you basically get 2 shots. After that, if you still haven't done it correctly, contact me. I've got a few of these left over from other modules. So the next thing we need to do now is just what we did before, where we mark where on the cell this temperature sensor is going to touch. So we'll take that last little piece of gap pad there, put it right there in the center. And now what we're going to do is we're going to take all of the bolts out, because just like on the 18S, we need to actually pull these apart. And on the Pseudo 12S, it's a little more difficult because once these come off of these standoffs, they're kind of hard to get back on. So just kind of do it very gingerly, like so. All you need to be able to do is see down into the sidewalls and then see the BMS connector this side. There's our BMS connector. And we will basically plop this down like so. And close this up. And just like on the real 12S, it's okay that the PCB is bowing a little bit here. It's not a problem at all. We will go ahead now and make sure just one final time that this PCB cannot move forwards and backwards. It is a huge safety risk if this can move left and right, because the high voltage here can touch the metal bracket, which can energize this entire assembly once it's assembled in the car. Right now, because the packs are taken apart and because none of these wires are hooked up, there's essentially 0 risk of you hurting yourself. So we'll go ahead and install the 12 bolts. Again, I'm only installing 4 here for brevity. You'll want to tighten them all the way as well. Okay, so that is the Pseudo 12S module.